Okay, hi everyone. I just want to start off by thanking everyone for coming to our Explorer webinar today, and we're happy to have you all here. So tonight we'll be focusing on structural engineering, and we'll have a special guest, Anthony, who is a structural engineer at the MTA Long Island Railroad. He'll be sharing some insights on his experience later on. So I'll get started by passing it off to Audrey to review the table of contents.
Before we get started, I'm just gonna do a run through of what we're gonna be talking about tonight. So to start off, we're just gonna start off by talking about what Explortal is. I think most of you probably already know, but we'll do a quick intro with that. Then we'll move on to what structural engineering actually is. I think Anthony can probably explain this best himself, but we'll do a quick little run through so that way everyone's familiar with it. And then we'll finally pass it off to our guest speaker, Anthony, and he'll discuss some projects that he's done, what being a structural engineer means to him, and what it's been like. And then finally, we'll have a Q&A section at the end where you guys can ask questions about what the career is like and what like schooling looks like for it as well. All right, I'm going to pass it off to Tiffany now, who will start our slideshow.
So, most of you already know what Exploral is, but I'll just do a quick rundown if some of you don't. So, Exploral is a student-led initiative bringing experienced technical career professionals to conduct hands-on STEM workshops in schools across New York City. So, basically, what we do is host these webinars or in-person events so that we can bring more experiences to those who aren't usually able to experience these things. And our mission is to bridge the gap between students and career professionals by offering these immersive learning experiences like in various STEM industries. And so far, we've had 6+ speakers from like leading companies such as Google, Lead, DI Group, Architecture, ASGNY, and AISNY. Sorry. And um, by this time, we have reached 885 plus high school students in many workshops. Um, Audrey, you can go to the next slide. So, what is structural engineering? And basically, structural engineering is the study and application of principles of mechanics and materials design structures that span or enclose space. So, structural engineering, it helps with the houses we live in right now, the buildings we work in. And it focuses on the design, analysis, and construction of safe, strong, durable, and economical structures. Some subfields include buildings, bridges, offshore structures, space platforms, amusement park rides, and structural retrofitting. So even the roller coasters that you ride on and enjoy, they require structural engineering to be able to function properly. So what structural engineers do is they design, analyze, and oversee the construction and maintenance of these structural frameworks. Next slide. So this is the basic career pathway to become a structural engineer. Obviously, um, you don't you don't have to follow this, but this is a traditional way. So first, you earn a BS in civil or architectural engineering from an ABET accredited institution, and then you take an FE exam, so the fundamentals of engineering, to become an EIT or engineer in training. And then you get an entry-level position at a structural or civil engineering firm and have internships or co-ops. After that, you work for a few years to gain experience and you collaborate with other teams so you can work on actual real-world structures. After that, you can go even further and earn a master's degree. Of course, it's optional, but you can specialize and that'll expand more career opportunities. And you also can complete around 4 years of relevant job experience under a licensed PE and stay current through continuing education so you can stay updated with the current information about structural engineering and the things that go on in the world currently. You can also qualify for higher paying jobs with more advanced duties. And lastly, but not least, you can take the PE or professional engineer exam so you can get licensed and actually have your own firm. So here are some of the challenges and rewards. So some of the challenges are that You have to have continued education requirements. So, for example, you need license. You need to maintain your license. You need advanced certifications, and you need to stay up to date. There could also be safety hazards on a construction site. For example, electrical hazards, material hazards, and height exposure. You can also get stress from so much responsibility and liability, and you could also get environmental and climate challenges. For example, engineers have to rethink stability and durability of materials sometimes in different environments. However, there are rewards such as job stability. Because we depend on buildings every single day, the job market for structural engineers is very stable right now, and there's high demand in both public and private sectors. You can also network, so you get global opportunities, and your skills can be applied everywhere you go. And it's also very impactful, and it directly contributes to structures and communities. And as well as that, um, demand comes with good salary, so you get competitive pay. So in total, you can get $103,000 average salary in the U.S. So here are some of the necessary skills to become a structural engineer. You need a project management skills. For example, you need to coordinate timelines and coordinate within your team. And if you're a team leader, you need to like manage the members. You also need communication. So you have to report well, and you also have to collab well. Attentiveness is also very important because buildings are need require very precise measurements and etc. You need to ensure that your precision is key. As well as that, you need critical thinking, so you need to address and solve problems. Um, One of the skills that is more niche is AutoCAD, but you can use it to draft and 3D model buildings before you actually start building them, as well as SAP 2000, so that's used for structural design and analysis. um, STAAD Pro is also used for the same thing, but it's just a pro version, as well as Excel, which is used for calculations. So, what is the difference between these two models that talked about? So, interface SAP 2000 is easier for beginners to visualize models, and it's also good for geometry, for example, irregular structures, and you use it commonly in academic research. However, for the pro, um, it's more complicated, so there's a learning curve, and it's good for steel structures as well as is commonly used in general construction. So now we're going to pass it off to Anthony.
Thank you, Tiffany. First, I want to say that was a great presentation. I don't think I could have explained structural engineering any better myself, so very good job. Hello, everyone. My name is Anthony Liccese. I am a engineer in the Long Island Railroad's structures group within the engineering department, so I work directly for the Long Island Railroad. A little bit of a background about myself. I graduated with a Bachelor's of Science in Civil Engineering from Manhattan College, now Manhattan University, in 2016. I began working with the railroad just a few months after my graduation, and in 2021, I obtained my professional engineering license. So throughout my college career and my actual career, I've had a whole different kind of experience. So I'm actually going to go in reverse order than it's appeared on the slides. So the first two summers, my freshman year of college and my sophomore year of college, I was an intern with the New York State Department of Transportation. My title was Transportation Construction Inspector. And one of the main goals, or one of the main things I learned in that internship, is basically learning the fundamentals of construction and maintenance contracts. Because one of the things that structural engineers, in addition to actually building the structures, we have to take care of them and we have to maintain them. I'll explain a little bit more about that as we go on. During my junior year of college, I took an internship at a private construction firm. Well, actually, they're a private engineering firm, but they have a construction management sector at STV. And during that internship, I learned the different components of construction projects, which include budgeting, scheduling, project management, contractor management, etc. My main project was overseeing the renovations of the Bronx County Courthouse by Yankee Stadium. And then after college, I began working at the Long Island Railroad. I started as an entry-level designer in just after graduation, and over the past few years, I've been promoted to engineer, and now I'm a senior engineer. And a little bit about what the structures group at the Long Island Railroad does is we are essentially responsible for all the railroad's infrastructure except the tracks. So all the bridges, all the stations, all the towers supporting the signals, all the office buildings, all of that stuff, it falls under my group. And we're basically responsible for maintaining all of the infrastructure as well as developing standards for building new infrastructure. So here's just a very, very brief part of some of the work I've done here at the Long Island Railroad. So I'll start off with the capital projects. Now, when I'm sure many of you have heard the term capital project when it comes to the MTA. A capital project essentially means it's a major construction project, that these cost a lot of money, and they're usually big major renovations or rebuilds. So the two photos in the upper left-hand corner are part of the capital project that's ongoing now. We're currently rebuilding our station out in Babylon, New York. So this photo actually shows us lifting the concrete slabs that are going to make up the train platform and putting them into place. And one thing you notice about that photo, yes, it is being taken at night because we cannot do the work during the day because we have to keep the railroad operating during the day because that's when we have our highest number of riders. So that comes to parts of critical thinking and management is how do you do a construction project and perform maintenance on an active transportation system without disrupting the general public who relies on this transportation system. So for this project here at Babylon, what we actually did is we cut the station essentially in half. So we have half the platform that's open during construction so passengers can use it, and the other half we demolish the old platform and rebuild the new platform. We also built all the platform pieces and segments that are each of one is about 16 feet long, and then we would come in at night with a crane and lift them into place. Another key aspect with this project is inside each of these platform slabs, we actually installed these little pipes that we can run a mixture of hot water and glycol in during the winter time so that the platform won't freeze during the winter and snow will automatically melt so we don't have to salt it every time that there's a snowstorm because salting platforms actually degrades their integrity and makes their lifespan shorter. So that's part of the capital projects. Other aspects we do is we deal with day-to-day maintenance on the railroad. The Long Island Railroad is over 190 years old, and a lot of our infrastructure is unfortunately showing its age. So this project over here was actually a maintenance request when we saw these concrete planks that were bridging the gap between two tracks. As you can see, one of them is failing or it's collapsing, and the others are bending excessively, which are signs that they're severely overloaded. So our task was we had to figure out a way to prevent these from deteriorating further and get them replaced in an applicable time. And then lastly, we deal with a lot of emergencies that happen on the railroad. So in this case, you see here, there was a truck that was too tall to pass under a bridge and he actually collided with it. So then when that happens, my group would get called out to go do an emergency inspection of the bridge, make sure that there's no damage, and make sure that it's safe to run the railroads and continue running the trains. But do you want me to read the conclusion? Or?
Oh, sorry. So, to conclude, structural engineering has the potential to change the world. And as we progress into a more advanced society, it's really important that we balance the safety, ethics, and creativity. So, with both precision and dedication, a more stable and innovative future will be right before us. So now we will transition to our Q&A.
If any of you guys have any questions, you can like raise your hand and like unmute and like speak, or you can also drop them in the comment section and I'll read them out loud. Bing Ting.
On average, I would say about once a week. Sometimes it could be twice a week. You know, sorry. Sometimes, it depends on the scale of the project or where the project is on its current schedule. Like right now, because it's the summertime and we have our ridership is higher, some of our major construction work will slow down, so we lessen the disturbance to the railroad. Emergencies are kind of unpredictable. They kind of just can happen at any given moment. But so once a week would be about an average, but it could be more, could be less. So how it works in my group is essentially everyone is assigned a week where you're kind of the on-call inspector in case there's an emergency. So they will call you. If something happens during that week, you're going to be the one that gets the phone call. But then if once your week is up, if it happens, someone else will usually get the phone call. Within my group, I'm usually on about maybe 5 weeks out of the year. So out of 52 weeks every year, I'll get about 5 or 6, depending on how the numbers fall.
All right, thank you. Eric, you have your hand up.
I was just wondering how like structural engineering overlaps with fields like architecture or like civil engineering, and if you had any interactions with them in the field.
Oh, absolutely. So architects kind of mainly focus on an appearance. They kind of want to make things look pretty. They want to they kind of want to have something that's unique and something that's really, sometimes they try to strive to see if there's something that's never been done before. Or there's another branch of architecture called historic preservation, where sometimes when we have to maintain a certain structure or rebuild a structure, we have to kind of build it and have it have the same general appearance as it was before. So as a structural engineer, our job is to kind of take their vision and make it possible. So sometimes in old buildings, what we do is we kind of try to find the design plans for those old buildings and see what they were designed for, and is it possible that with modern day construction standards and regulations that we can preserve the structure. Or, in the case of a railroad station, we kind of want to make our stations have a welcoming feel, but also have to make sure that they're being supported in a way that they're going to withstand the elements and all the loads that they are anticipating. So there's a lot of cross references between structural engineering and architecture. And it's kind of common, I think, for structural engineers to become very good friends with architects. There'll also be a small share of disagreements from time to time, but usually we can work them out.
And when you do like test the architect's like plans out, do you like simulate it or like actually try building it first?
So nowadays we kind of will run computer simulations of it. So we could actually model structures and buildings in structural engineering modeling software, and then we can see, okay, if an earthquake of this magnitude would hit this area, how's the structure going to behave? If a hurricane with 150-mile-an-hour winds were to sweep through the area, how's the structure going to behave? Is it going to stand, or is there going to be danger?
Thank you.
All right. Kai, you have your hand up.
How long would you say each like project as an engineer lasts, or how long would you work on it?
I would say that really does depend on the project. So a lot of the transportation projects that I work on over at MTA have an average of about 3 to 5 years from start to finish. But the start time of a project actually happens long before there's a shovel in the ground to start the actual construction. First there's a lot of different studies. You have to make sure that you're not going to disrupt the environment. You have to also reach out to the community and the public to get them notified to see if this is something they're going to be okay with, and if they want to know how the project's going to affect their daily lives. And then we actually have to run through the design and analyze the design and take a look at, okay, this is what we're planning to do. How are we going to build it? How is it going to disrupt our service? All of that could take about 2 years before we actually start putting a shovel in the ground and start the construction. Some smaller maintenance tasks, though, can take anywhere from a couple of weeks to just a couple of months.
I have another question.
Sure.
Would you say you ever get moved around projects, like where work is needed?
Oh, absolutely. It's not uncommon, actually, to be assigned maybe 2 or 3 different projects at the same time. So it does require a bit of time management and prioritizing and understanding where each project is in its phase of its duration. And another thing that I've actually kind of been discovering more recently, employees are going to retire, or sometimes they're going to resign. And usually when that happens, the project doesn't just stop because whoever was working on it is no longer part of the firm. So sometimes you'll end up having to pick up the slack of that employee or carry on the progress of that project until they get a new engineer to come on and help you.
Okay. And I'm just going to read some questions off from the chat. So, can you tell me more about the courses involved in your structural engineering degree?
Sure, absolutely. So like I previously mentioned, I went to Manhattan College, and they had a very, no pun intended, structured curriculum for structural engineers. So freshman year is usually calculus, chemistry, physics. They have a couple of courses that kind of give you a broad overview of the different types of engineering. They also have a course where they do a lot of teaching of how to use Excel, which is a very, very important thing to understand and be able to learn, because Excel is going to become one of your best friends as a structural engineer. In sophomore year, you kind of start to take courses known as statics and solid mechanics, those are kind of like introduction to specific structural engineering disciplines. Then as you move on to your junior year, you'll start to take structural analysis, which is the complete analyzation of different structures, as well as you'll start to take materials classes, which you understand how different materials work in construction. So steel and concrete are both great materials, but they both have their pros and their cons, and understanding how one works instead of the other can be the difference in deciding on what material to use in your project. And then senior year, we close off by taking courses, more advanced structural design courses, as well as there's a final senior design project that you generally present to your engineering professors at the end of the year.
All right. Thank you. And I'm going to read another question in the chat. What
Sure.
do you think are the most challenging aspects of structural engineering?
Most challenging aspects. I need a minute to think about that one. I would say figuring out the answer to a problem that you've never seen before. So a lot of engineering is creating something that wasn't there before, whether it's a new building, a new bridge, a new railroad line, and there's always going to be issues with it. And basically our job is to kind of figure out how to make it work. You can, and sometimes you can build a 20-story building in one location, and if you go maybe 3 miles away, that exact same structure might not work because there's different site conditions. Like maybe the soils you're using aren't as strong as they were, so you have to reevaluate. Or maybe there's, the water table is a little bit higher, so it makes the soil really moist and not good for building. So there's a lot of things like that that you kind of have to really kind of take a step back and really apply some critical thinking skills.
All right. And another question from the chat. Do you have any advice for high school students looking to pursue structural engineering?
I would say definitely be ready to work hard, but don't be afraid of it. Any college career you take, any major you choose is going to require a lot of work. So you're going to have to put time in. There are going to be times when you're going to have those late nights studying, or in an engineer's case, trying to figure out some particular problem or a homework assignment. But also don't be afraid of something you don't know, and don't be afraid to make a mistake, because that's how you essentially end up learning and understanding.
All right. Thank you. Jasmina, you have your hand raised.
So you mentioned that you have to work at night sometimes. Like, how often do you have to do that?
That doesn't happen very often. I would say maybe once every couple of months. Sometimes I can go maybe 6 or 7 months or even a whole year without working at night.
All right. And another question from the chat. What is an experience that really opened up opportunities in the structural engineering field for you?
That's a good one. I would say the opportunity I have to grow really close to my classmates in college and my professors. A lot of college professors actually have worked in the engineering field, so they have a lot of networks and a lot of connections. I actually got both my internships in college through my college professors who sent an email to people they knew and they were able to set it up. So definitely the networking opportunities, I would say, were a major, major factor in helping me get to where I am.
Okay, and another question for the chat. Do you think it's required to keep advancing your education, like with exams and further studies?
So ever since graduating college, the only 2 exams I've ever taken were the FE and the PE. Actually, let me rewind a bit. I actually took the FE while I was still in college, which I would highly recommend you do if you are pursuing a career in structural engineering. And I can explain a little bit more about that if you'd like. But there are continuing education post-college is really more of attending webinars or attending lectures, and kind of listening to professionals in the industry share their experience based on their studies. Like a lot over time, design codes or material standards, those things always get updates based on current events. A lot of things that we're finding now in the world is with hurricanes and storms becoming more powerful and flooding is becoming more and more of a concern. How do we design structures for these flood concerns in areas that really weren't prone to major flooding in the past? So continuing education is a very, very important. And also, when you go to these webinars, you do meet other colleagues that are in the industry, and they can always share their knowledge, and you can share your knowledge, and you help teach each other.
All right, sounds great. Winnie, you have your hand raised.
So I was wondering how long like your projects typically last, and if you need like a lot of patience to become a structural engineer.
So a project can generally last anywhere between 3 to 5 years. That's what, at least the projects I've worked on, that's how long they've last. Some projects can last more, some projects can last less. And I would say any career you choose is going to require a lot of patience. And a lot of that patience does come sometimes from dealing with or having to explain things to people who might not have the same background or understanding that you do. So in my instance, because I work with the Long Island Railroad, I deal with a lot of people who don't have backgrounds in structural engineering. So sometimes I have to remember, like, I can't explain certain terms the way I know them because they might not understand. So it's kind of having to be patient with that understanding people don't have the same knowledge that you do. Or the same, I shouldn't say knowledge, just same background that you do.
Okay, Eric, you have your hand up too.
In regards to climate change, like, is there any experience that you had while working on a structure where you had to work around the weather?
Yes, there's actually been times we've had to cancel some projects because of heavy rain or lightning in the area. When lightning is nearby, it's not safe to really be operating cranes or lifting massive structures and putting them into place when it's very windy, because that poses a safety hazard. We've also had to kind of think outside the box in the way we design some of our structures. And sometimes things that we just kind of used to build directly on the ground, now we have to design elevated platforms for them to prevent any flood damage.
All right. I hope that answers your question, Eric. And another one in the chat. How involved are you in field inspections compared to office-based analysis or design?
I would say for my job specifically, because I am more of an office-based designer, but we do have a segment in my group that does do inspections on a day-to-day basis. And they're generally responsible for doing the annual structural inspections. Most entities, most building owners, most agencies do require their structures be inspected annually, and they usually have a group that'll take care of that.
Okay. And then another question from the chat. What do you think are the biggest pros and cons of this career path?
Which one do you want me to start with? Pros or cons?
Let's start with the cons.
Okay, so some of the cons is it sometimes does require long days, long hours. It's not going to always be your typical 9 to 5 job. It will sometimes having to go to places or specifically projects or construction sites that are going to require you to sometimes walk on uneven surfaces. And sometimes it does involve getting down and dirty. You know, sometimes when you go out to the field on an active construction site, there's dust, there's mud, water, all these kind of things that can that you can encounter. Some of the pros: structural engineering has tremendous job security. There's always a need for structural engineers. You know, whether taking care of existing structures or trying to build new structures, there'll always be a demand. Also, the pay is very, very well. Ashley, are a lot of the guests in this meeting, are they based in the New York City area?
Yes. So typically, from our webinars, they're attendees from like people that we publicize to, which are in New York City and around like from our school. So.
Okay, because I saw you said the average salary for an engineer is about $103,000. I would argue that's kind of low compared to structural engineers that work in this area. But I will also say that you're not going to come out of college with a $103,000 salary. You will have to work a couple of years, but you will get up to that very quickly. When I started, I was making $89,000. And then I would say within about 3 or 4 years, I was making $110,000. So, and you do get to meet a lot of really nice people from all over the place. And you get to have a lot of interaction with colleagues. It's a very people-driven organization. You know, it's not really a lot of independent work. It's going to be a lot of teamwork and working with a lot of different people from a lot of different backgrounds. And I find that rewarding because then you get to learn about different cultures or lifestyles that maybe you didn't grow up with or are not familiar with. You know, I've worked with people who have grown up in different countries and have immigrated here, which has been very rewarding to hear about their stories.
That sounds great. Oh my gosh, thank you. I learned something new today. Just read off some more questions from the chat. How have the benefits outweighed the challenges of structural engineering for you personally?
So I think that the benefits are much easier to look at than the challenges. So for me, I kind of, when weighing the pros and cons of structural engineering, I feel that the pros outweigh the cons because I think they're just so much more rewarding. And kind of understanding that everywhere you go, there's going to be pros and cons. And I feel that the pros in engineering outweigh the cons of it. I hope that answered the question.
If the person in the chat wants to elaborate, if that did. In the meantime, I'll move on to the second question. What do you wish more people understood about the work of structural engineers in rail systems?
I wish they understood that it's not, they can't always have full access to the construction site. So it's not like, you know, when you're building a building from the ground and you can just close off the area and you have the whole thing to yourself. In an active rail system, we're always going to have to keep running our trains. And, you know, I think sometimes some people in the it does affect how projects are built in the construction schedule and the timelines, because it involves, you know, having to schedule things during off hours. And, you know, usually when you schedule work on weekend or overnights, you have to pay your employees overtime, which can sometimes drive up the costs. On the other hand, you know, sometimes I wish that people understood that they should be a little more lenient, because one of the reasons why that when they question why a project is, you know, having a lot of overtime or high cost, it's because these are the only hours you're allowing us to work. So it's kind of like a double-edged sword that I think I wish kind of both sides would better see each other's point of view.
All right, it's a very interesting analogy. Someone from the chat responded back to the other question. It did thank you. To add on, is there any experience that really stuck with you? I think they're referring to your structural engineering experience.
I would say an experience that really stuck with me was after a meeting I had when I, first started at the railroad. I was there for maybe about a year, and I all of a sudden now had to be the head of this meeting with higher ups, like, the railroad's chief engineer. And I had to basically run through the whole scope of a project from start to finish. And I remember after that meeting, the chief pulled my direct boss aside and said that you found a good one. So they were very impressed with that. And it was nice to get that recognition because it made me have that appreciation that I love to feel, that everyone would love to feel. And it kind of felt like it kept driving me to continue to work hard.
All right, and then another question from the chat. Would you say experience matters more than education in this field, or do they kind of go hand in hand?
I was hoping someone would ask that question. I would say they go hand in hand. So I would say experience is just as important as your education. I can tell you that someone who has a 4.0 GPA and got A's in every single engineering class, but never had any internship or research opportunities during their summer months, as compared to a student who maybe had like a 3.0 GPA but had an internship or a research opportunity every summer. The person with the internships and the research opportunities but the less GPA is going to be definitely more marketable. So you definitely want to make sure you get that experience, especially during your college years, because it definitely helps you apply some of the principles you're learning to some of the problems that you may not see while you're in college. I've kind of discovered that, college really kind of only teaches you a very small portion, and then a lot of it is kind of learned on your day-to-day experiences in the job.
Very interesting. I actually have a question of my own. Do
Sure.
you think as a structural engineer, obviously there's a lot of like physics, math involved. Do you think you get the chance to be creative or to like innovate new things?
Absolutely. I would say half the job is just being creative or innovating new things. Whether it's not and even if the structure itself is basic, sometimes you have to be creative on the way you're going to build it.
Do you have any examples or like any situations where you can talk about?
Yeah. So I'll go back to the project at Babylon. So basically a train platform is over 1,000 feet long. And, there's no way you could lift something that's 1,000 feet long using a crane. Now, we don't want to basically pour the concrete on site because with trains passing by, trains create a lot of vibrations. So the concrete's not going to cure. So the solution we came up with was to actually just make smaller chunks of the platform and lift each one into place and kind of put it together like a puzzle. And another creative aspect on the same project is to address the issue with the snow melting. Because when we put salt on the platforms, salt is very, very bad for almost any structure. Generally, salt is the reason why we have potholes in the road. So if we don't want to have to, replace the structure again in 30 years, we wanted to come up with a solution. So we thought, well, what if we put these little hoses inside the platform and we can run a mixture of warm water and glycol that can increase the ambient temperature. And therefore, it's not going to be cold enough for snow to stick. And it's had very successful results.
That's very interesting. That's very interesting about the experience. Some other questions from the chat. Would you say getting internships and extracurriculars is really important? And since most of the calls, most of our attendees are high school students, I'm sure you're probably well versed with like extracurriculars in high school. I know not now it's very hard to get a job without prior experience, even if you're fresh out of college.
So I would say, yes, extracurricular activities and internships are very important. So I'll just jump on the extracurricular activities first. One of the things I've noticed that extracurricular activities help you do is they help actually show that you have time management, where you can still balance getting a decent education, but also doing other things at the same time. Regarding internships, they're just as important. I know a lot of places are I don't want to say they're discouraged, but they generally don't hire high school students. I'm not saying they're not out there, and you definitely should search for them. But if you don't find one, don't be discouraged, because you'll always have the opportunity to get one during your college career. And, sometimes even internships, they want students that are in like junior year or sophomore year, because they want to train that person. Hopefully they come work for the firm and get a job. So regarding the comment about getting a job, one of the nice things is a lot of engineering firms do have what they call entry-level positions, where those jobs are actually specifically catered to people who don't have experience working in the engineering field or only have a few months from working summer or winter internships. Actually, and it's pretty common that, if you go to work for a firm, they can sometimes offer you a job when you graduate. So that's part of where the networking comes in. Because internships and extracurricular activities will also teach you networking, which is a key important part of any career you choose to go down.
Okay. And other questions from the chat. As humanity uses more space, what do you think will happen to professions that deal with construction and building?
I think there's going to be a high demand for them. I think as humanity does use more space, we're going to need to build more homes, more schools, more rail lines, more bus lines, more roads, more highways, so we can continue moving and transporting people around.
All right. And then other questions in the chat. How helpful do you think higher education, like a master's or PhD, is when it comes to finding a job or advancing in structural engineering?
I think it depends on what you're ultimately wanting to get out of your career. So I don't have a master's, but the kind of work I do, it doesn't require a master's. And a lot of other colleagues I've spoken to have really said that a lot of people like to see more that you got your professional engineering license or your PE over a master's. I'm not saying a master's is bad, because sometimes having a master's or having that extra education might make you look more marketable when you want to go for a higher paying engineering job or a promotion. So it really, I guess it kind of depends on the work you're doing and ultimately what you want your career to be. If you want to, a lot of structural engineers go into research and they research the behaviors of different materials. They'll work in labs a lot, applying different possible scenarios. If you want to do more research based, then I think continuing education is important, because a lot of them have PhDs and master degrees.
Okay. And then other questions from the chat. There are so many fields within engineering. What made you choose structural engineering?
I can give you the short answer Or I would say the answer that I knew that I first wanted to be a structural engineer was I used to love playing with Legos when I was a kid. And then I would say, I've always wanted a career in construction and in engineering. So when I was kind of started my senior year of high school, I started researching around. Like, I didn't actually really know much about engineering when I first started my senior year of high school. So I started looking at, how to become someone who designs buildings or how to become someone who builds buildings. And that's when I started seeing the term structural engineer.
Very interesting. Do we have any more questions? If so, you guys can raise your hand. You can pop them in the chat. Oh, there's another one. Do you think structural engineering is a more hands-on field or more computer-based? How often do you spend your time outside/inside?
I would say about 50-50. I will say it's definitely becoming more computer-based because we have a lot of softwares and systems that can basically do calculations that sometimes would take us many hours. They can pop it out in a couple of seconds. But also, you do have to go out to the field to see what's going on. If I design something, I want to make sure that it's getting built per my design. Or almost anytime you design something during construction, there's something that's going to come up and they're going to need you to come out on the field to take a look at it. Because something you may have assumed in the office or may have thought during your design, it turns out it's not the case.
Okay. And then another question from the chat as you're talking about becoming more computer-based. Someone said, now that AI is advancing, how would it impact structural engineering?
Well, I would say AI could definitely help in help us in performing complex calculations or analyzing different services. But I don't think AI can really take away a lot of the field work of engineering or a lot of the drafting. So like the development of drawings, maybe AI could be used as an assistance for it, but I would find it very, very difficult to have a computer do something from start to finish. I definitely think structural engineering is one of those terms or one of those fields that will always need human interaction and human oversight.
All right. So just to follow up on that, would you say that the job market for structural engineering is very safe,
Absolutely.
even with AI progressing?
Absolutely. I think AI is going to help us do our jobs. It's not going to take our jobs.
Okay, sounds good. More questions. What mistakes did you make early in your career that others like us can learn from?
So, are you gonna? I'll give you both. I'll give my early in my college career and then early in my actual career. Early in my college career, I would say one of the mistakes I made was not really taking advantage of all my school had to offer by either getting involved in student organizations or visiting the Career Development Center to do practice interviews or work on my resume. I kind of always thought that there's always going to be time for that. And I feel that it was kind of a struggle when I saw other classmates, progressing and getting internships, and I was still trying to find one. And a lot of schools will have like student chapters of the American Society of Civil Engineers, which is a networking that a lot of that a lot of professionals join. And these events joining the student members. I'm sorry, joining the student chapter of these organizations can help put you in contact with real professionals out in the industry, which is always good to meet professionals and get networking and contact. in my post-college career, I would say one of the biggest mistakes that I made was not asking enough questions when I didn't know the answer to something, fearing that I would come across as incompetent. You know, it's engineering is always a teamwork, and we're always going to be helping each other. So never be afraid to ask someone for help or assistance, because that's the only way you're really going to
All right, and we'll take one or two more questions as we're almost hitting the 1 hour mark. So you guys can just drop your last questions or like speak up in the chat. And yeah.
Ashley, I'm going to drop my email in the chat. If anyone ever has a question or they want to reach out or, you know, just kind of have another discussion, you can always feel free to email me and I'll be happy to answer or help in any way I can.
Yeah, absolutely. I'll share them after to all the emails after the webinar. So
Okay.
it's great. All right. Last call for questions. Okay, I think that everyone kind of has all their questions answered. So now I'm just going to wrap up and end the Q&A session. Thank you guys all for attending, and thank you, Anthony, for coming and speaking about your engineering experience. I'm sure a lot of us learned something new today. I definitely did. And yeah, thank you guys all. Have a great night. And Anthony, if you want to stay back, we can speak a little after.
Sure. Thank you so much for having me. I was happy to be here.
Yeah. All right. Bye-bye.
Take care.